So I realized that I learned all this stuff through YouTube videos, and it was mostly through James Briggs and Sam Witter or something. They're both really good, and I'll drop the links in Discord. Um, but the email I sent is just words, and it's not really easy to understand without seeing actually what I'm talking about. And I know I just talk a lot, and it's not easy to imagine. I'm a visual learner too, so I need to see it. So I think I'd make a video describing how to do certain things. So I think about this as a knowledge transfer of what I know to you guys, so you guys can have all the tools that I have, and we can work together from there. So what I want to cover in this video is how to load PDFs and how to transform the data, how to upload that data into a vector database, and then how to chat with that database. And then we'll go even further and make that database a tool using LangChain. We'll add that tool to an agent, and then we'll add more tools to that same agent, and we can see where we can go from there. Just show you like some possibilities of how deep we can go with this. Another thing I'm going to show you guys is Huggingface. Huggingface is this, and it kind of lets you upload data sets and models, and it has a lot of cool stuff. I think you should look into it. So we'll be uploading our PDF document once it's finished to Hugging Face, and then connecting the Hugging Face to Pinecone to upload the data. Another thing I'll show you guys is how to chat with a PowerPoint. So a lot of things in my classes do PowerPoints, and this is probably the most basic thing. So I think we should start with this actually. So I'll drop this file in the Discord, PowerPoint summary, and run this code to download the required packages. Okay, and then what you want to do, I download the PowerPoint up here, chapter 10, PPX, and you just drag that over here. You press here, copy path, and you put it in there. This is using LangChain document loaders to load PowerPoints. LangChain document loaders has, I'll just run this window. So check out the LangChain, Python and LangChain integrations and the documentation here. There's a lot of cool stuff. This is where you learn everything really. Document loaders. So as you can see, they have a lot. Just a bunch. ChatGPT data, Discord data, CSV, EPUB, all this stuff. So in this example, I'm using the PDF loader, which is not in this one. Oh, is in this one. Okay, so these are the main ones, and I pressed the integrations over here. This is integrations. This is like third parties made these. This is actually by LangChain. And so if you go to PDF, you can see the code needed to run this. And so if you go here, I run that code, and then it's loaded into documents. And then it extracts that text, and it just gets a huge, or not really huge, but this is the text from, it's a good amount, text from the PowerPoint, right? And this text is literally just this PowerPoint. Super simple, pretty cool. So you get the text, and I'm using, and we'll just run that code real quick. And I'm using GPT 3.5 Turbo 16K, and we're using OpenAI functions here rather than LangChain functions. The difference is that these are less customizable, and it's just a different way. Like, you see how I'm saying I'm like pre-prompting it? So this is like kind of telling the system who they are, and then as a user, I'm sending in the PowerPoint text with another prompt. So yeah, I'll just display what happens real quick. Yeah, I just run this one. It's the same thing. So I believe. Oh yeah. So let me explain this better. I'm saying you're an expert at pulling important words that college students probably don't know from PowerPoint presentations that will likely be in the show in the upcoming test. You're given a PowerPoint on the chapter for a class. There's an upcoming test in multiple chapters, but this is the most important chapter to know. Pull 20 words from the PowerPoint and provide a definition for each. List the words with their definition in your regular list. Only pull words from the PowerPoint. Okay, and then it does it like right here, and then the next message sent is the text from the PowerPoint. So since this is the 16K token one, and I'm maxing it out at 7,000 tokens, it can take in all of that PowerPoint text and this message beforehand and actually output this. But I don't think the regular GPT 3.5 Turbo could do this because it was just maxed out on tokens. And then you can upgrade the tokens to 16K here, and you can change temperature. The temperature is the randomness. So if you put it at 0, it's going to go word for word what was in the context. And if you put it at 1, it's going to be pretty random. Okay. And so as you can see from this PowerPoint, it pulled some words that the person might not know, but right away, internet and network, internet service provider, like these aren't that good of things. These words, I think everyone would know that. But it gets better down here: broadband, DSL, cable modem, coaxial cable, ADSL. Like, I don't really know what those are, so it's good that it just gives you vocab words based on the text that you can study. And I believe right here, yeah, here's a different prompt. So I'll run this prompt now. Playing around the prompt is pretty cool too, because that one's for vocab words. This one is for practice tests, so study guides, practice tests. You're given a PowerPoint, upcoming test, multiple chapters. This is the most important chapter to know. You format your study guide like this: title, summary, description, main talking points, 10 practice questions with 3 answer choices each, correct answers in the next section, correct answers with their corresponding numbers. I feel like it's with the correct answers right below each question because it really messes that up, but we'll play that right later. So formatting the output is not advised to be done through a prompt. This is just kind of like the easiest way to do it. The best way to do it is through like output parsers, which we'll go into later on when we talk to our PDF. But it actually doesn't put the answers right below each question, it does at the bottom, which is pretty cool. Okay, so it does a summary of the PowerPoint. It says the main talking points, and then it has 10 practice questions. So this is really helpful for before a test. You can just go through every single PowerPoint that the test is on, and then you can quiz yourself pretty much, like super easily. And then this is pretty cool for lectures too. You can do the same thing. But what would be even cooler, and what I was trying to tell you guys I was imagining, is we have a metadata field that so we upload the PowerPoint text. We upload the same way we'd upload a PDF text, and we label each chunk of text with the chapter that it's affiliated with. So this is chapter 10. So all these chunks of text would be affiliated with chapter 10. And then there's a PDF textbook that has chapter 10 in it as well. And then there's a lectures that have chapter 10 affiliated with it too. And that's in our vector database. And we can then call that. We could say from chapter 10, make a study guide with 10 questions and do the output parsers to get exactly the output we want. So we could have a practice quiz 1, a vocab 1, a study guide 1, whatever. And that can be really, really valuable because you can have the entire practice exam and you can redo it, change the randomness a little bit, and be really cool. So super helpful stuff. I'll give you guys this notebook. All right, now to the next thing. This one is gonna be loading the PDFs, okay? For this one, I'll load my business data communications textbook. It's a pretty large textbook, so it might take a second, but I'll talk about Huggingface when it's loading like that. So this is the PDF loader. I guess this is from this isn't through LangChain, I don't think, even though they do have one. I think this is just ChatGPT helped me do this one. Um, oh, what is that? I think I was starting to collect open source textbooks. Maybe we can go in there. Yeah, sure, why not? Okay. I don't know what to ask. I guess we'll digital marketing. Yeah, cool. All right. I've never seen text before, so I was just making a folder of them. Open source, so it's not illegal. Although you guys should use the ones for your classes because I guess it's not illegal to use it for yourself. I think it's illegal to do it for commercial use. But we can talk about that later in different discussion. I want you guys to use these tools for your classes now and actually play around with them and try to get the best outputs possible that actually help you learn better and can give you more insightful information. So I don't I don't like promote you guys to use it for your quizzes to like cheat. I promote it more to use it for study guides and asking any question really and getting whatever answer you desire. Oh, so Huggingface. So this is gonna give me this notebook is gonna give us a JSON L file, JSON lines file, and we're not gonna directly put that into Pinecone, although we could. Um, just the way I know how to do it is through uploading it to Huggingface and then connecting the Huggingface dataset to um, Pinecone and uploads that way, which is it's just the way I know to do it. So here we define extracting the text in the PDF. This extracts all the text, and then it gets the ID, the source, which is the page number and the page content. So if you guys remember before, I want to add another field here called chapter, right? And getting the page number is easy. Making an ID is easy because that goes with each page number. The page content is just the text. So that stuff's doable. That stuff's easy, right? But I hope that in this project, in this group, I want you guys to try to figure out how to use that NER, like named entity recognition, to come into this function and try to find the name of each chapter. And if you could see that, if you saw a PDF, you could see that every textbook has the first few pages are like table of contents. And so I'll show you here that this is my, these are the data sets from my other business data communications. So my other textbook. So this is the first one I did. And this is what ours is gonna look like right now. It's gonna be an ID, text, and then the page number, right? But what I want it to look like is this. And this has the ID, the text, page number, and chapter. So ideally, you can ask a question and it'll return what chapter and page number you want. But as you can see here, this is table of contents. And then when it hits the last chapter of table of contents, it says chapter 11. And for the rest of the document, it says chapter 11. So it's flawed. The code isn't that good. I don't know how to code. I'm just trying to play around with it. I hope that you guys can hopefully figure out how to apply a chapter to each chunk of text. That could be extremely useful. So right here, we're just extracting the text and super easy, extracted to JSON.L. This formats in the way I want. Here, we're going to tokenize it. So tokenizing it is pretty much applying a ID to each chunk of text. Let me show you here. So it's these chunks are pretty big. You can play on the chunks you want, but as you can see here, it says -0 and -1. It's the same first ID, but it says -0 and -1. This means that the chunk is from the same page 7. And that's just a good way of keeping the same source and different chunks of text with a similar ID. So that's all we're doing here. and we're getting it ready to vectorize it. So the chunk size is where you determine the chunk size. It really, there's no perfect chunk size, but you can play around with it. Take it as you will. That this is gonna be the output. It's gonna be this big pretty much. You can go bigger. You can go smaller. It doesn't matter. Um, I'll go 500. And then this is encoding it, so it's applying the IDs and making it into a JSON L file. And then we just download that file. Cool. So if you go to this notebook, which I'm going to give you guys, this is the code I use to try to extract the chapters. It doesn't work, but I hope you guys can play around with it and try to extract them yourselves. The only difference is pretty much this chunk of text. So now what we're going to do, we're going to go to our Huggingface account, press new data set, and we'll do this digital marketing, because I think that's the name of the book. And I don't have a license, I just press other. Oh, maybe not. Cool, whatever. Be sure to make it public because it has to connect to the Pinecone database. I don't know. All right, I don't know about licenses. Maybe you guys know more than me. I don't know. So you go to files and versions, and upload file, and then you just go here, upload the JSON-L, and commit. And then the dataset card, you'll be able to see the data. And it comes to the pages, looks pretty good. The data doesn't look very good though. The PDF loader didn't work too well. This arises like reasons why we maybe should use the LangChain document loader for PDF, because this does not look good at all. This is really low quality. As you saw in my other data set, it was much higher quality than this. I don't know why. Yeah, they all have like spaces in between the words. Super weird, but let's see if it works. So let's copy the data set, and let's go over to this notebook, Huggingface to Pinecone plus query. And so this is the Pinecone, and I hope you guys have made an account. It's free to have one index. So I have one right here. I'm gonna delete it so we're on the same playing field. It's free to have one. It costs money to have two, but you can really fill one up like crazy. And so we're gonna play around with how much we can do with one, and then if we should move to two at some point. And I can add you guys, and eventually can add you guys my organization, and we can work together, collaborate. So yeah, let me do that. Copy your Huggingface dataset name, and then you go to Huggingface, or go to this notebook, and load that data. Side note in Huggingface, you can go to the datasets, and they have a bunch of, they have a bunch of open source datasets you guys can use for yourself to chat with, and they're mainly used to train LLMs, but because like retrieval augmentation requires high level, like high accuracy data sets, they're used to train LLMs. Retrieval augmentation should be like, you should know what the data is really well. But it's also used for fine tuning, which is pretty cool. And we're gonna work in fine tuning later on in this project. So we load all that good stuff. Let me get my API key. Don't steal it. I'll know who stole it. Okay. And then here we'll get our Pinecone API keys. So you go to Pinecone API key. You put it in here. And then you can call it really whatever you want. I'll call it, yeah, I think you can't do caps, but I'll do rag testing. Right? And that's connecting to our Pinecone account. And if there's no database, there's no index in the system, then create index. That's what it's doing here. And then the 1536 goes along with the text embedding ADA002. And during this project, I encourage you guys to not use text embeddings ADA002 because it costs money, and there's extra. I mean, it costs like very little money. Like this will cost like 2 fractions of a cent. But there's a bunch of open source embedding models that I don't think are as good, but some people think they are, and they're free. So they're just kind of as good, and they're free, and so you can put that model name in here and do whatever you need to do to initialize that model. But when you do that, make sure that the dimensions are different because each model has its own dimension of vectorizing. For ADA002, it's 1536. And so we haven't added our data yet, so the index fullness and total vector count should be 0. Here, we're actually going to batch the text up into 100. I believe that's what's going to happen. Or the batching, I'm not really sure about. I think it might be, I don't think it's chunking the text again. I think it's getting 100 batches of chunks and adding them at a time. I think that's all it is. But yeah, that's probably what it is. And we're adding the text and the source to the Pinecone index. Sometimes people just do the text, but since I want to do retrieval QA with sources, we're going to do text and source. And a downside of that is that I haven't been able to find an agent that can do text and source. So they can usually only do text for some reason. We have to look into that as well. I've seen examples where they do text and title, or they do 2 fields, but for some reason with sources it doesn't work with the agent for some reason. But I'll go back, delete my index, and then show you guys just text and what the agents look like and stuff like that. So vector count is 326, really small textbook. But you should see how there's vectors in there now. It filled up. And if you go to your Pinecone indexes, see there's nothing there. When you reload the page, we got rag testing. Okay. This is defining the text field as text and defining our vector store for LangChain as Pinecone. LangChain has the ability to do to connect to multiple vector stores or different vector stores. I guess it'd be integrations. Right, so these are all the vector stores it offers. There's a bunch. I think Pinecone's the best, but people do swear by Chroma as well. Chroma is open sourced, I believe, and yeah, it works pretty well. I like Chroma too, but Pinecone, it's more long-standing. You can have it in there, and I think it's better for larger things. So we'll still go Pinecone for now. So we did digital marketing. So what is digital marketing, right? This data is really bad. Digital marketing strategy. This data is really bad. It's all messed up. Why is the chunk so small? The chunk should be really long. The chunk should be hundreds of 500 tokens. So super weird that it's that small when we return it. Because I mean, even here it's kind of large, you know. Okay, that's not good data. Not good data. But we'll survive. So For this, we're going to do QA with sources. So we get the page number that the answer comes from. So this is from a previous prompt. Given the answer choices to answer this question, is it a question? And the question was true, false, network profiles, blah, blah, blah. And the answer was true. And you can find the answer being true in page 231. So super helpful I was doing this for an assignment to get the answer plus where I can find it in textbook to look for myself. So let's initialize that. And right here, we're defining our LLM model. For this version, GPT 3.5 Turbo, it's pretty cheap and temperature's at 0 because we want it to be exact and actually find exactly where the text is in the chunk and not, be random. This is initializing memory. So we could say, what is that? It'll be like, it'll know we're referring to network profile. It's pretty cool. And it saves up to 5 memory things. And then this is a chain that we're going to use. So this is the chain I was talking about. When we index the text and the sources, we want to use QA with sources to get this sources thing. If we use a different chain, like just retrieval QA, it won't return the sources, but it will return this. And I just think returning the sources and letting someone go to there and make sure that the answer is actually accurate is very valuable. But the agents are also very valuable. So it's like, what do you want to lose? And I think with some research, we could probably find an agent that's compatible, that can provide sources too, and maybe you can play around with output parsers to do the same thing. But we'll go into that soon. So we'll ask the same question. What is digital marketing? Digital marketing is the use of digital channels, technologies, blah, 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 blah. It says page 26, page 1, page 12, page 21. You see over here, page 26, page 1, page 76. Doesn't use page 76, which is pretty good because there's nothing there. But as you can see, it goes to the pages with this is just bad data, but it goes to the pages and it returns what pages was used. With good data, it actually is really cool and really accurate, which is awesome. So let's do a different example. This data is really bad. I'm going to connect to the other textbook, which is already uploaded, and this is super easy to go into. And then oh, actually it's in here. Sorry. So I'll actually play around with this and I'll leave this in there. I'll leave that textbook in there, and I'm going to add another textbook. I'm going to add my business data communication textbook, and that is that's this one. Okay. All right, that's weird. But we just saw it. It's there. That's super weird. Maybe it's whatever. It should work. So we're loading this from Huggingface. And then we're going to add this to our Pinecone database. And as you can see, this one's a little bit bigger. It has 4 columns, text source, chapter title. Chapters aren't correct. And then the number of rows is 931. This is just deleting duplicates. We don't really need that. And then let me just I'll give you guys this notebook, the Huggingface Connect notebook, the PDF loader notebook, and the PowerPoint summary notebook, by the way. For this, we'll do this. To enter your Pinecone API key, and then your Pinecone environment. We should all have the same one. And then this name is the wrong name. So do rag testing. Apologies. So connect the index, and we can see that this still has the last textbook in it, the 326 vectors. Okay, and then we've already connected to this data set, which is already pre-transformed from our PDF loader, it's ready to go. And we just go here and we add it to the vector database now. Oh, wait, actually, yeah. I said wait because I didn't know if we were gonna add the text and sources, but since we're gonna work with agents, we should only do text. I'm hoping that the other data being with sources doesn't mess this up, but let's find out. Now we have 1200 vectors in there. And then we'll query what is Wireshark. And as you can see, this data is a lot better. This class is about like networking, so Wireshark's included in the book, and it just gives you the most relevant chunks of text based on this query. This is super cool for like anything really. If you have small amounts of data that aren't from textbooks, and this is just a semantic search really, and you can get as much results as you want. So if I want to do 5 results instead, I get 5 results rather than 3. So it returns 5 chunks of text, right? I can do as many as I want, as few as I want, and it goes from the most relevant to the least relevant. Super cool. Okay, so one thing different with this one, the different thing is retrieval QA. It's not retrieval QA sources, it's just retrieval QA. And so for this one, we'll just do QA.run. So it's like, and it responds with a natural language. This is retrieval augmentation, like at its finest, right? It retrieves a chunk of text, augments it, and generates it in a natural language. So what ChatGPT is getting, it's getting this. It's retrieving that, augmenting it, and then generating an answer in natural language, right? And so this can be used with a lot of different things. Really cool. Now, we're going to define this as a tool for LangChain. And by doing this, we can then add that tool to an agent. And agents have a framework of how to work, agents kind of have large language models talk to itself. It says, what should I do with this query? Where should I go with it? Which tool should I use, or should I use a tool at all? Should I use my normal knowledge base? Do I know the answer, or do I have to use a tool to find the answer? It has the large language models talk to itself in a really cool way, and this stuff's really powerful. And there's some like baby AGI and God mode, if you guys use that. They use agents to kind of do really cool things. And learn more about agents on YouTube or the LangChain documentation. I really highly recommend it. They're really cool. So for this one, we're gonna use chat conversational React description agent. There's a bunch of different agents, but that's the one we're gonna use for this one. It just works the best for what we're trying to do. It's just very simple. It's one of the simplest ones. And then we'll do the query. What is Wireshark? This is what's happening. It says, where can I find this answer? The best way to find this answer is my knowledge base. My knowledge base has Wireshark in it. Okay, let me query semantically Wireshark. And then it finds the observation of being Wireshark is whatever. Like it knows what Wireshark is from the knowledge base. And then it says, okay, I have a final answer. And the action input for the final answer is this. It says Wireshark is a network protocol analyzer that allows you to capture and analyze network traffic. So it has ChatGPT check itself and kind of be like, it makes it more powerful in a lot of ways. Yeah, let's keep going. So what if we asked a math question? The book was about business data networking. This is a math question. 2 times 7. See how it doesn't go to the knowledge base? It doesn't use the action to go to the knowledge base. It knows automatically the best answer is found in my knowledge base. I know the final answer. It's 14. So that's really cool when it's not just for like a specific use case. It kind of just enhances its ability. Because then people can ask normal questions they would ask ChatGPT and it can just answer them like the same way ChatGPT would answer. Tell me some facts about business data networking, whatever. Goes knowledge base, makes an observation. The title of the book mentioned the provided context. Okay, let's see the final output. Business data communication networking is a field focuses on the study of application network technologies. Pretty cool. It provides the answer in a natural language, right? But another cool thing is that because we're using the conversational agent, as you can see here, and we have conversational memory right here, that means that when we do any prompt, the previous ones go into it. So we can say, can you tell me more about that? So we won't say anything else. We say about that. And it still knows to go to its knowledge base and like a conversation answers the question. Let's say, can you tell me about chapters 4, 5, and 6 for all right, can you tell us about the chapters? This is what we really want to do. I'm sorry we don't have access to specific content. It only has the raw text, the chunks of text that we actually gave it. So hopefully in the future we can do that. Okay. Now, what if we add another tool to our agent? So imagine our agent is like, I guess like a handyman or like a gunslinger or like a jack of all trades. And he has all these tools on his tool belt and he can choose which one he wants to use or use himself. And himself is being ChatGPT and they can choose which ones they want to use. So for this example, we use DuckDuckGo search. It's like an API search. It's a tool mentioned in LangChain documentation. There's a bunch of them here. Bing search, that's probably a better one to use because that's pretty much exactly what ChatGPT is right now. 11 Labs, I want to work with this later on. This is text-to-speech, speech-to-text, really cool stuff. 11 Labs, they're probably the best ones with text-to-speech. And then this is the one we're going to use. This is just like a search API, searches the internet. So we install the packages and then we import these fields. I don't think this is like necessary. These aren't all necessary, but this was just from a different video with the Sam Witherspoon guy. And I just recommend looking at his video to learn more about it. He can explain it way better than I can. So let's just import these and be safe. Okay, and so I redefine tools. And I also import the search DuckDuckGo search, right? So what I'm doing here is I'm saying import the ability for me to make a tool. And I'm making my own tool, which is the knowledge base. And that was done earlier, but knowledge base uses information when in general knowledge. This goes to the vector database. This tool does. This tool calls an API, which is like super powerful that it can call a vector database and an API on demand, like whenever it wants. And tools can also be like hard coded. It can just be straight code. And it can be like, know when to use this code, which is like wild. So it asks itself, what tool should I use? And then it uses it for certain situations. And when AI is getting more and more integrated into the real world, these tools may be really important. These agents may be really important. How they work is going to be super important. So definitely do a lot of research on agents and tools. These are super powerful, and try to create or use the most like the craziest tools you guys can think of, I guess. Like I really encourage that. But this is really simple. This is just learning about it. I really don't think that DuckDuckGo search is that good. Honestly, I think the Bing search on ChatGPT is better. But it still is a tool. It still works. So let's use it. We just define the tools, and then we say, since the function is search.run for DuckDuckGo search, we're just going to run that to see what the answer is for this. So for this example, I wanted to use the archive. This is a website on Cornell University. Like, they post like research papers, research stuff, right? It's on the internet. It's up to date. They post new things all the time. So ChatGPT is not trained on this stuff. So for this example, I want to use this. So what's the evolution of reinforcement learning? And return the object, return the answer. Reinforcement learning is extremely powerful in general machine learning, blah, blah, blah. The issue with this is that it went to the internet and it found the top answers and it responded with those. But as we know, the internet can be a weird place. So we want to, in this situation, I want DuckDuckGo to only go to archive to find the answers to my questions. So this search tool is now a search only for archive. How do we do that? Well, we can actually put that at the beginning of the prompt. We can just say cite archive.org, what is the evolution of reinforcement learning? And then we know it goes only to archive. As you can see, it presents a different answer. We present rlight. It did mention rlight here too, which is pretty impressive because I think rlight might have only been mentioned. I went here before. That's why I said reinforcement learning, the evolution of reinforcement learning. I thought rlight was only mentioned here. But as you can see, title is long-term project with reinforcement learning, and it says we present rlight. And the answer is we present rlight, long-term evolution, extremely modular, and open source framework. So what it's doing here is that it's searching the web, finding the most relevant web pages from archive.org, scraping them, and then retrieving that information and augmenting it, and then generating an answer. Like super fast. Like, look how fast it is. Crazy fast. It's nuts. But we don't want to write cite archive.org before every query. So we're going to hard code that into our tool, make a duck wrapper, just find duck wrapper, and then search.run, but then before the input text, we just run this these words real quick, and that goes to a specific site, which is really powerful and really cool and could be used for a lot of different things. We redefine our tool as search archive, so it knows, and I give definition of what archive is, scholarly subjects in physics, mathematics, blah, 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 etc. Define that, define our agent again, and then we could do let's try, so I stopped here obviously, but let's try let's see if this works. Okay, cool. So it did the search archive thing and it find the final answer. Cool. What about will it search archive for this? It will. Let me find something that it found a good answer there too. So that's not a bad thing because it found the best answer. Let me find. I'm trying to have it go to the textbook. What is business data communications? Really? Oh, I redefined tools. Hold up, give me a second. Maybe that was the issue. I forgot to do this. Okay. Hopefully this works. knowledge base. Beautiful. So it knew to go to the textbook rather than search archive because the best answer is found there. And then you could still ask, what is 9 times 8, right? And hopefully, yeah, doesn't need to go anything. It just knows the answer is 72. So I hope you guys play around with this. Look into the tools available. Change the agent. See what happens there. Try QA with sources with an agent because I think return the sources is really cool. And then also look into output parsers. I'll give you a brief description of what they are right now. So this is from the other guy, and he did the same thing. This is where I got it from. He did the site. He hard-coded the site image before the DuckDuckGo search, and then he said, answer the following questions as best you can. And he did a medical site as the site. But you're a compassionate medical professional, and you have access to these tools, and it's only the one tool, DuckDuckGo search. And then use the following format. It gives it a format, and then remember to act like a medical professional, whatever. And then here's the input. So he's prompting it, but he's also defining the tools in the prompt and defining the input in the prompt, which is really cool. And then later on, he actually goes even further. And what does he do here? I believe he makes the output into a JSON format, which is really cool. But I advise you guys I'm not wasting more time. Look into this video yourself, and I will add these notebooks and that video so you guys can play around with it for yourself and chat with your own PDFs, chat with your own PowerPoints, chat with your own whatever website you want from the DuckDuckGo search. Or I would advise to use Bing, but I think Bing costs money. Look through the tools, look through the agents, look through all of this python.langchain.com/docs. They're mainly through integrations, but I think that's all for today. I'm sorry for the very unstructured video, but I hope this helped you guys more than the emails did. And message me if you have any questions, and have a good weekend. So I'll see you guys later. Bye.